సార్ ఈ బిఎన్ఎం కావాలి ఎవరు సార్?
Prakash sir, is it audible to you?
Yes, sir.
Okay, okay.
వినపట్లేదండి.
Prakash sir, is it audible to you?
Yes, sir.
Okay.
Yeah. Sir, you are audible.
Good afternoon, sir.
Namaste. వినపడుతుంది. నేను వినపడుతున్నానుగా.
Yeah.
Very good. It is audible.
Yeah, good afternoon to one and all. Myself, Dr. T. Srinivas, Professor of Civil Engineering and convener of this faculty development program. It's my honor to introduce respected Director of GRIT, Dr. Jandhyala N. Murthy sir, respected Chief Guest and today's speaker, Dr. KSS Trimurthy Naidu sir, respected Principal of GRIT, Dr. J. Pravin sir, respected HOD of Civil Engineering, GRIT, Dr. C. Lavanya Madam, and my dear all the participants of various engineering colleges across the state. A warm welcome to this one-week faculty development program on advancements in construction material and practices during 13th to 17th February 2023. An objective of this FDP is to help the faculty to update and enhance the knowledge on advancements in construction materials and practices as part of lifelong learning process. As we know, faculty are the role models for the students. So it's our responsibility as a teacher to update the knowledge and skills and share the same thing to students. This FDP has eminent speakers with vast experience in industry. So it is a good opportunity to all of us to learn many things, what is happening in the field apart from academics. This FDP covers the topics on significance of green building design, performance and durability of cement concretes, innovative materials and emerging technology in building construction, importance of civil engineering in electrical power transmission, role of digitalization and artificial intelligence in construction industry. All the very best to all of you and happy learning. Now I welcome Dr. C. Lavanya Madam, HOD of Civil Engineering, GRIT, to say a few words on this occasion.
Thank you, sir. Good afternoon to one and all. Myself, Dr. C. Lavanya, Head of the Department Civil Engineering. So in GRIT, Department of Civil Engineering established in the year 2008 with BTech of 60 students. And we have started MTech program in structural engineering in the year 2014 with 18 students and further increased it to 30 in 2017. Both the programs, BTech Civil Engineering and MTech Structural Engineering, are having MBA. And in the department, we have well qualified and dedicated faculty in total of 22, out of which we have 7 PhD faculty and 9 faculty are pursuing their PhDs right now. And also department is very good at consultancy and very active in research. We have more than 250 paper publications in various reputed journals and conferences, which are indexed in Scopus. And consultancy of worth, we have done more than 90 lakhs. We have already conducted 5 national and international conferences in the department itself. So like one more important point regarding the research facilities, what we enhance or what we have with like loading frame of 200-ton capacity, NDT test, electrical resistivity, etc., which are available and are used efficiently by the faculty and the students for the benefit, for the publication, paper publication, projects, etc. And like today's FDP, we have conducted many workshop FDPs for the benefit of the faculty, so that to identify the latest technologies, real-time problems, and also to identify the gaps which are there in the curriculum perspective. This FDP is exclusive because all the speakers of this FDP program are from the industry. Personally, on the behalf of department and personally, I thank all the speakers for sparing their valuable time. So definitely this FDP program, the output of this outcome of this FDP will benefit the faculty for sure, and there will be many takeaway points. Thank you all. Happy learning.
Okay, thank you, madam. Now it's my pleasure to welcome Dr. J. Praveen sir, Principal of GRIT, to share his views on this occasion.
Okay, thank you, sir. Are you able to hear my voice?
Yes, sir.
Okay. So first of all, I would like to welcome all the participants and the guests to this 1 week faculty development program on advancements in construction material and practices from 13 February to 17 February. Respected Dr. Janjal Murthy Garu, Director GRIT, and respected speakers, Dr. KSS Trimurthy Naidu Garu, Dr. T. Venkateshwar Rao Garu, and other guests, Dr. Lavanya, HOD, Civil Department, Dr. T. Srinivas Garu, the coordinator for this FDP. So, warm welcome to all. So, I just want to, as we have number of participants and guests from different places, so I would like to introduce GRIT in nutshell. So, GRIT is established in year 1997. So, recently we have completed 25 years silver jubilee, and our main theme is we are providing excellent education in engineering stream. So we are having NAC A++ accreditation with CGPA 3.55. With this, we are in top 5% of the colleges, best performing colleges in across India. And also we have NRF rank 148. So out of 5,000 to 10,000 colleges, so our rank is 148, which is very nice to have this type of ranking. And we have UGC autonomy till year 2031. So if autonomy will give huge scope to have our own curriculum and best practices, our own best practices. And all the programs are eligible programs are having NBA accreditation. 6 UG programs and 5 PG programs are having NBA accreditation. Total we are offering 15 programs, 9 programs in BTech and 6 programs in MTech. We have right now 325 faculty members. Out of them, 110 faculty members are having PhD. And GRIT is having 1200 lakhs worth research grants from various funding agencies like UGC, ACT, DRDO, ARDB, etc. And we have multiple funded projects from ACT like Prerana Scheme, Skill Development Center, Margadarshan Scheme, FDP grant, Atal FDP grants, conference grants, research proposal scheme, MODRAP. We have 1 crore worth Idea Lab, and we have ACT Distinguished Chair Professor Scheme. So all these things are from ACT, and from DST we have fixed grant of 100 lakhs. TechCube 2, we have 400 lakhs grant from World Bank. Then MSME, previously we received 50 lakhs, now 75 lakhs. Right now 5 ideas, we are now working on 5 ideas in this incubation center. And GRIT is having zero recognition, that is scientific industry research organization. And every department is encouraged to conduct international conferences. So like this, civil department is conducting ICONCES, where the publications are coming in E3S Scoopus Index Journal. Similarly, mechanical engineering department conducting ICMPC, where the publications are coming in Elsevier. IEEE CFET conference, where publications are coming in Explorer, IT Explorer, as well as journals. Then the 3 departments, civil, electrical, and EC departments are recognized research center from JNTU Hyderabad. And we have ACT CAI Platinum ranking. So this is a ranking with respect to industry linkages, and GRIT is having highest ranking. Similarly, Atal Innovation ranking, we call it ARIA ranking, and we are in the band excellent. So these are all the all great achievements are with support of our stakeholders, faculty, students, parents, employers, etc. Coming to this advancement in construction material and practices. So if you see every day, there are new things are coming in construction. So for example, sustainable material. So as if you see Hyderabad or the places which are having huge growth. So how to really maintain this city sustainable, and how to really have sustainable material. So all civil engineers required to think about the sustainable materials and similarly 3D printing in construction. So the new things coming in construction is 3D printing construction. So already you are seen. So already a few IITs they already demonstrated they are printing entire building, maybe duplex house. They are printing with 3D printer, and similarly smart materials. So we need to improve quality. So we always see so many challenges like cracks and other things coming up. So because of advancement in technology, we have smart materials. So how to use these smart materials in the construction of buildings. Similarly, prefabrication and modular construction. So because of technology, so most of the places we are able to see this type of prefabrication and modular construction. So how actually we need to train for faculty and students in this area, we can discuss on those things. Similarly, advanced material and coating. So different type of materials are coming. So how we can use, for example, nanotechnology. So can we have such materials in construction? Similarly, advanced construction techniques. You can see a lot of new machinery now is used in construction. So we need to introduce these things to our faculty members, students. Similarly, BIM, that is building information modeling. So previously construction was simple, but now because we are planning very huge cities, smart cities, then huge construction buildings, maybe very big software parks, etc. So if you think about a software park, so we can only plan with BIM kind of things. So many you have drainage, then you have fire safety, then you have electrical wiring, then air conditioning, then so many IoT devices. So constructing a building or a software company kind of thing. So it has a lot of complexities. So after planning, initially in the planning level itself, we have to have the blueprint of that building and how all this. It's not civil engineering means not only the building and material. We need to think about all the fire safety. Then we need to think about electricity. We need to think about many things actually. So previously construction was only brick and you can say cement and bricks and steel, etc. But now it is not like that. So entire electronics, electrical, mechanical, air conditioning, everything you have to embed into the building if you want to build a smart house or smart city, etc. So all these new challenges are coming. So hope in these 7 days, all our participants and speakers will deliberate on all these advanced technologies. So I wish all the best to all the speakers as well as the convener and HOD civil engineering, and I wish that they have to conduct such more this type of FDP seminars and conferences so that we'll be knowing what is happening in the industry as well as what are the best practices at GRAT. So those things also can be shared. So thanks for giving me this opportunity. All the best. Thank you.
Okay, thank you very much, sir. Now it's my honor to welcome today's speaker, Dr. KSS Trimurti Naidu, sir, to start the session. Before start the session, I request Mrs. G. Sweta Madam, Assistant Professor, Civil Engineering, to introduce the speaker.
Sir, good morning, all of you. Sorry, good afternoon, all of you. Satya Sai Trimurti Naidu, he is presently working as a technical consultant to Nadu government of AP. He did his PhD in civil engineering from JNTU Hyderabad. Prior to this, he completed MTech in structural engineering and BTech in civil engineering. He has vast experience of 34 years in AP government sector at various levels of superintendent engineering, executive engineer, and assistant executive engineer in buildings, roads, and bridges. He is expert in project management in infra projects, procurement, contact administration, and coordinating client contractor consultant vendors. As Superintendent Engineering, Panchayati Raj Department, Prakasham District, he was in role of sector expert and procurement specialist in rupees 2,200 crores APDRP project World Bank. He has published 8 research papers in various Scopus journals and conferences, and also published a textbook on performance and crack healing efficiency evaluation of fly ash based bacterial concrete. Thank you, sir.
Sir, please go ahead with your session.
Yeah. Yeah. Thank you, everybody. Thanks the management of GRAT. And I thank the director, the principal of GRAT, the HOD of Civil Engineering Department, and can I share? I also want to mention what are 2 points pointed out by presented timely by our principal regarding 3D printing in the construction and modular and prefabricated units. Now it is need of the hour. In the next sessions, we will have some interaction on it also. So I share my PPT regarding this.
Is there any problem, sir?
The screen is not fully visible.
Otherwise, we can share it, sir. No problem. Shall we share, sir?
Yeah, share it.
Okay, sir. Okay.
Yes, now it is visible. Can I continue?
Yes, sir. Please.
Yes. Who will be moving the screen?
Vivek, sir. Vivek, sir.
Yes.
Yes.
So thank you. Regarding the present day discussion or present day talk is regarding the performance and durability of the cement concretes. Because already we have good structural designers. They are designing the structural elements, buildings, roads, so many things with M30, M40, or M50, or M60 concretes, with specialized concretes, with good working conditions and good loading conditions, etc. The need of the hour is already we have gained vast experience in this, attaining the strength of the concrete members, designing the cement concretes. So the need of the hour is, one of our speakers, just our principal or somebody mentioned about sustainability. Sustainability reflects about the performance and durability of the cement concretes. For the last 34 years, after 35 years in the industry, I am more concerned about performance and durability of the concrete. Next. Because already we are good at attaining the strengths, good at attaining the design requirements, etc. So the need of the hour is performance. Yes. Next. The strength and performance durability, both are the main parameters. Already we have good knowledge in strength, but our practices are not that much as at the standard level regarding the performance and durability. Next. So we are discussing more on performance and durability. Now, performance and durability, I consider it as the same thing, synonymously. Performance, durability due to external loads, but we discuss now microstructure and constituent materials in this talk, because external loads, it's very huge topic. They already external live loads, dead loads, snow loads, so many other wind loads, or moisture, or sea water, or so many things. There is external loads and microstructure and constituent materials. These microstructure and constituent materials play an important role in durability of the concrete, strength and concrete durability. So, our main tasks, there are two things: how to get the strength of the cement concrete. We are already very good at it. Now, our task is how to improve the performance durability of the cement concrete. So, our present discussion more depending on performance and durability of the cement concrete. We all know very good now is cement concrete strength depends upon the design properties, standard execution procedures, coarse aggregate, pan aggregate, and use of admixtures, plasticizers, and pan vibrators, construction practices, etc. We don't discuss about the strength of the concrete in this session now. We discuss more on durability and how to attain the durability. Right. So, what is the durability? Here, see, I have shown one picture also about the failure of the durability. What is the durability? Durability is, we all know that a sustained withstanding for all the conditions, all the loadings, all the weather conditions, and perform well and sustain. That is in nutshell about the durability. Next, I concentrate more on the other slides where I am more interested in the images and practical photos. Here, what is IS 456 2000 is saying more about it. Our IS 456 is now next coming version also is concentrating more on performance and durability of the cement concrete, because the need of the hour present day, what is going on, our structures are they have to stand at 100 or 120 years, but some of the structures are not that much durable. So IS 456 2000 and revisions also next coming version also is concentrating more on the performance and durability properties and the conditions, the procedures, how we have to implement regarding the durability of the concrete. So IS 456 is concentrating more on the microstructure and physical properties of the concrete, such as low permeability, low free water, environment. So ingress of these acids, sulfates, carbon dioxide, carbon monoxide, oxygen, other dangerous and deleterious material. So 456 once again is concentrating which are the built-in protection factors we have to concentrate more, how to make it more durable, what are the activities we have to incorporate in executing our concrete structures for durability, how to codify the durability requirements. Here, the IS 456 is trying to codify the durability requirements. So it has all over the world, the durability of structure means once our structure is durable for 30 years or 60 years or 90 years, then your investment, you are investing for 90 years, it is very good. If it is failing within 30 years, your investment is gone. So it is a national loss or loss to the entire country. So durability of the structures in other terms is nothing but investment in terms of hundreds of thousands and crores of rupees, lakhs of crores of rupees. So durability means you are creating an asset for another 30 years or 20 years. That is my contention. That is the contention of the industry. That is the contention of the IS 456. That is the contention of the industry experts. So why I am emphasizing more means you are making a structure more durable means you are creating asset for another 20 years, another 30 years. Thank you. Next. So IS 456 also once again in detail is concentrating about the ingress of water, ingress of chemical solid liquids, the ingress of hydrochloric acids or oxygen, carbon dioxide, chloride, sulfide. All these things will attack the structure. So when these things attack the structure, the structure will not be durable for more than for the design period. So the structure is designed maybe 30, 90 years or 100 years or 20 years. So if the structure fails due to all these things, in 30 years means you are again to invest double the amount. So one structure of 10 crores durable for only 20 years or 30 years means next you have to invest at least 200 crores or 300 crores for that building. So in the other terms, you are avoiding all these sulfate acid attacks or acid attacks or chloride attacks, sulfate attacks, and make it more durable. You are again contributing to the wealth of the country. Thank you. Next. So these are the main factors. Generally, these are the academic things. I don't concentrate more on academic things because we are all faculty members, so we have very good knowledge about it. Free water in the concrete, or exposure conditions, humidity, permeability, or porosity, chemical resistance, chloride resistance, resistance to alkali reaction, formation due to the connectivity. Next, these are academic things. I'm not. So my main focus is how to reduce the permeability. Once you reduce the permeability, once you reduce the pore volume, once you reduce the pore connectivity, or you interconnectivity of the pores, how to make it a concrete impermeable. These things will increase the life of the structure. So my focus, I request our faculty members, there are so many procedures in reducing the permeability of the concrete, reducing the pore volume, reducing the pore connectivity. There are so many conventional methods or chemical methods or admixtures are there, mechanical admixtures are there, chemical admixtures are there, mineral admixtures are there. So many things are there. Let us try to find out if any other procedures are there to improve the permeability, decrease the pore volume, reduce the permeability, reduce the pore connectivity, and make it concrete more permeable. Let us try to think on these terms. Let us think on these points. So once you decrease all these things, the migration of salts, other dangerous chemicals, all these things will be avoided and reduced. Because my experience, I see for the last 32 years, the concrete is permeable, more pores are there, more interconnectivity of the pores are there, more seepage connections are there in the concrete. It makes it chemically very dangerous in the durability condition. So concrete must be finally physically and chemically more durable. Next. 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 How to address the factors affecting the durability of the concrete? So once again, some of the words may be repetitive. Maybe I may be repeating 1 or 2 times because in the flow of that thing, some of the words may look repetitive, but in the interest of the subject, in the interest of the topic, they may look repetitive, but they are very important. So low permeability, fewer pores, less or no free water, and the quality is high performance concrete, that is which is more durable. Thank you. Next. So one of the structures you see here, a bridge is there. A bridge is there. So physically you can see, I am more interested in the images, the diagrams and sketches as a practical engineer. Here you can see It is a water, the water condition is there. It is a beach. So the strength of the durability of the concrete depends upon the winds, quality of the construction, environmental conditions. It may be saline water. There may be saline humidity, more humidity. So many things here. When you see the big, so many conditions which are affecting the durability of the structure, you can assess it. What are there in the books? The factors affecting the durability. Beyond that, as research persons or academicians or industry people, we have to think, and we have to our vision shall be beyond the points where which are written here. Next. So once again, these mechanically, I am defining it: low permeability, high workability, high strength, high modulus of elasticity, high density, high dimensional stability, high performance concretes which are more durable. So when low permeability means with less prone to the chemical attack, so more durable. This is academic thing. Ingredients of cement concrete, we all know: cement, water, coarse aggregate, fine aggregate, and admixtures. Next, this types of cements. This is academic. We know OPC cements 43, 33 grades of concretes. Nowadays, our multi-storied buildings are we have now here. Structure of cement concrete. I am more interested in that as a field engineer, as I'm more interested in execution as well as academics. Here you can see the aggregate, coarse aggregate or 20 mm or 12 mm thick, how the load transfer mechanism takes place in the concrete. When the load is applied on it, how the load is transferred from the coarse aggregate to the matrix or cement paste, and again to the other coarse aggregates. Is it transferred from coarse aggregate to coarse aggregate, or coarse aggregate to the cement paste, or cement paste to cement paste? Different combinations are there. So the better optimum combination we have to design, we have to evolve to make the structure more durable. Once again, I am trying to analyze this image more. You can see 20 mm metal there, or some fine particles are there. Cement paste is there. We are not worried about the other routine conventional procedures which we study. We have to think beyond that. Load transfer mechanism, how it depends upon the microstructure of the cement concrete. Coarse aggregate, constituent materials, coarse aggregate, fine aggregate, or cement paste, and other voids. Next. 1 minute. Here you can see the microstructure. The aggregates you can see. The cement paste also you can see here. Similarly, the voids also you can see here. I am more concentrated on the microstructure of the concrete in the backdrop of how to improve the durability of the concrete. Again, I emphasize on the microstructure of the concrete, the load transfer mechanism, how we can improve the load transfer mechanism better, efficiently. What is the load transfer mechanism? Is it from coarse aggregate to fine aggregate, or coarse aggregate to cement paste, or cement paste to cement paste? What is the transition zone? How it affects the coarse aggregate or cement paste? How it affects the load transfer mechanism? How it improves the durability of the concrete? Next. Say, here I am trying to explain about the microstructure of the high performance concrete, which is more durable. You can see the coarse aggregate material here. You can see the cement paste here. Here, silica fume, which is filling the voids. I am trying to draw your attention to the silica fume. In the earlier side, we have seen the voids. Here, your silica fume, a reactor powder silica, is trying to fill the voids, the gaps, the voids within the microstructure of the concrete, which will increase the life of the concrete, which will increase the durability of the concrete. Next. So now we are driving our attention to the engineering microstructure of cement concrete. So we are trying to engineer the macrostructure. Our duty as academicians, or research people, or industry people, our concentration is, see in the left side, cement particle packing. The load transfer mechanism will not be that much efficient because there are voids in it. In the conventional concrete, some of the gaps are not filled, not packed completely. So once again, I emphasize on microstructure of the concrete in the load transfer mechanism, and which drives to the better durability of the cement concretes. There we can compare both the images. So one is with looser packing. How to achieve the better packing in the right side? Here you can see there are 3 or 4 types of other materials with a better, denser packing system. This is the schematic representation of the cement concrete, cement paste in 2 images. So we have to improve not improve, I say technically, we have engineer the macrostructure, and thus you have to fill up all the voids, make it denser binding material. The cement paste shall be not as a simple cement paste, it shall be denser and no voids or less voids, and make it a denser and better packing, the engineered macrostructure of the concrete, so that it will improve the durability of the concrete, and we will, in other terms, we will extend the life of the cement concrete structure. Once again, because I'm academically, I'm not that much interested in the definitions in the other typed material, which I have seen for the last 30 or 35 years in the industry, where the concretes are failing, where the durability is decreasing, where we are field engineers or industry people are not that much efficient, and how to improve the durability. In these things, I am more interested. So I am concentrating more on the images, diagrams, and sketches. Say, once again, regarding the porosity, pore volume, voids, and all those things. Here, I gave you 2 samples. In one sample, the water cement ratio is 65. In the other sample, the water cement ratio is 25. 25 or 30 is the optimum water cement ratio. Beyond that, the excess water makes the cement paste or cement concrete more porous, more permeable, with more content of pore volume. Then, so what I am trying to drive you is how to execute cement concrete structures with optimum water cement ratio, or 25 or 30. How to avoid excess cement water cement ratio, how to reduce unrequired, unwanted water. Once again, unrequired water and unwanted water in the cement paste or cement concrete beyond 35 or 25, which is undesirable, and which makes the cement paste or cement concrete structure, cement concrete element more porous, with more values of voids, more pore value. Make the ultimately all these things make the structure undurable, gets damaged, concrete. The concrete is not sustainable. Ultimately, the structure's life is reduced. This will explain words and words, miles and miles. We can speak about volumes and volumes, how excess water is harmful to the cement concrete, harmful to the durability properties. It is against the sustainability of the concretes. So here two pictures. You can see in one picture, left side, the coarse aggregate particles, coarse aggregate elements are suspended in mortar. Here in the other model, the coarse aggregate particles are closely packed. These two things. Here, the excess water is playing a major role, causing the major damage. So we have to, as academicians, as industry people, as a research people, we have to concentrate more on the systems, on the procedures, on the techniques, how to engineer, how to evolve the procedures of reducing and avoiding the excess water, which makes the concrete that less durable, which damages the life of the concrete. Next. Here you can see another problem. Here I am more concentrated on the images, pictures, problems, and site conditions. Ultimately, the need of the academicians, need of the industry people is how to handle the problems faced in the industry, in the field, in execution. The leaching of structures. It is a retaining wall actually. Similarly, you can see here at some shades on the slab projections, on the columns, the leaching of concrete. Somebody says that even some of the engineers not aware that the leaching of concrete is making the concrete structure porous. It is dislodging the free lime and make it capillary force interconnected in the structure. So the problem here, you can see by once after 3 years or 4 years or 20 years, day by day, the retaining wall which we are seeing here is becoming porous. Pore volume is increasing. Intercapillaries, pore capillaries are interconnected. So the external attacks of oxygen or carbon monoxide or sulfates attacks, etc., will attack the reinforcement, make the structure weak, make the structure less durable. Leaching of free lime is a major problem in OPC cements, where excess of free lime is formed during the hydration of cement. So leaching of free lime or avoiding free lime in the concrete structures a major problem in our cement concrete structures. Next. Here, in one picture, I'm trying to show you 3 types of aggregates and cement concretes. Number 1, no pore spaces. So it's very closely packed. I am more concentrating on the images, diagram, and sketches. Less on, once again, emphasizing. So our ultimate aim is no pore spaces in the concrete or non-porous and non-permeable. Number 1. In the middle, you can say there are some pores of remarkable size, but the pores are not unconnected. Now the porous material now, because they are not connected, may not be permeable. So it is to some extent non-permeable. For a period of time, it may become permeable. Next connected pore spaces. Here, the third example, same I am seeing here, the connected pore spaces. The pore spaces are connected, intercapillaries are connected. The porous the total concrete is permeable and porous. Next. Next. Similarly, here you can see the capillary pores connected with high permeability. The need of the hour. Most India is having so many thousands of kilometers of coastal area, and there are so many places in Kerala, Karnataka, or in UP or somewhere where the rainfall is more than 100 centimeters per year. So regularly the concrete structures, the buildings are exposed to the rainwater. This rainwater, how it affects the cement concrete structures, which pores are interconnected. Capillary, here you can see the pores are interconnected, and there is every possibility of saline water attack or rainwater attack, which is having more oxygen, or similarly chloride attacks, or sulfate acid attacks, or acid vapors, or saline water, or so many things. Once the capillary pores are connected, once there is high permeability in the structure, there is every possibility the structure in the due course of time will fail and will be less durable and will fail structurally. Even though the building may not collapse because of the design load, there are so many safety factors. But I personally see most of the some of the buildings where the beams are cracking, the slabs are cracking, there is interconnectivity of pores. You can visualize it, you can see it where the water is leaking, where the seepage is there, where the lime is leaking, where the porosity is there. Everything you can see once the capillary pores are connected, high permeability is there. This makes the structure less durable, and it will be very dangerous to the structure. So one of the examples here I am seeing this. The pores are connected. The surface water is reaching the reinforcement. Once the surface water with the dissolved oxygen and the dissolved gases is reaching the reinforcement, means the structure is gone. The rusting is started. The cancer is started. Cancer of the reinforcement is started. There is no procedure in the world to reverse the rusting of the reinforcement. The only method is to avoid the rusting of the reinforcement with better construction procedures. You cannot, once it starts the process of rusting, means the building is gone. You can temporarily repair it or to some extent restore it only, but you cannot get the original strength of the reinforcement, original structural stability of the structure. So the connectivity of the capillary and capillary of pores and rusting of reinforcement is a dangerous problem to the durability of the concrete, to the sustainability of the buildings. So excess water cement issue, already we discussed in the earlier slides. Excess water cement ratio will cause, it will occupy more space in the due time, and it will cause more pore voids and more pore volume and interconnectivity of the capillary pores, and increase the permeability of the concrete as mortar, and it's very dangerous. Next. So once again, I try to impress upon you regarding the transfer mechanism. Pores, 20 mm are fine aggregate, coarse aggregate and fine aggregate. Next. This is regarding the practical kind of unstable mix regarding the durability of the concrete. Unstable mix is it's non-cohesive, segregating. Mortar, one location is deposited, 20 mm fine aggregate is deposited in one location of the member. It will cause very endurable scene and endurable content. Stable mix. It is a routine practical exercise with better design and better mixers, better coarse aggregate, fine aggregate, cement design mix, and better construction procedures. Schematic. So here I am trying once again the aggregates, cement paste, binder, and the voids. Next. Next slide. This is just a cross section. Coarse aggregate and fine aggregate matrix. Yes, here. We all know everything about the 20 mm HBG size metal. It is a single size metal which you use for concrete. Here I am trying to impress upon you, in single size metal, there will be more pore space in between the coarse aggregate material. 20 mm coarse aggregate single size metal, there will be more voids. The packing will not be that much close. In the next slide, we will see. Here, graded metal. So, single size metal or graded metal. In the graded metal, the voids are more packed. So, the load transfer mechanism will be better efficient if you properly design the concrete member with a graded metal with proper ratio. It will increase the durability of the concretes. So single sided metal or graded metal. The option I suggest for graded metal, properly graded, properly size is sieved, fineness modulus is correctly obtained, and design a proper mix with HPC graded metal of 20 mm or 12.6 mm sizes. It will increase the durability of the concretes. And some other research also has to be done regarding these issues also by the academicians and research. These are the different grades of sands we use. Or generally we use rough sands of zone 2 or zone 1 or zone 3, depending upon the type of construction or mixed design and fineness modulus. And next, characteristics of durability properties of concrete. Here, I will emphasize on low porosity, low permeability, resistance to chemical attacks, early strength and continued strength development. So here I want to make you draw your attention to the continued strength development, how it is attained. So continued strength development means here earlier we have seen the leaching of one of our retaining walls with the free lime. So this free lime utilized and reactive powder silica is added to the 2% or 3%, 5% as per the design. That you can have this property of continued strength development. Early strength of 7 days or 14 days, and continued strength development next to 30 days, 90 days, or 180 days, or 365 days. So what is the role of this continued strength development? Somebody may ask me a question. Already strength is attained. What is the need of? Yes, there is need of it, because the free lime which is already there has to be consumed. One point. Next point, it has to add to the strength of the. It has to improve the quality, and you have to have the quality of continuous strength development for a period of time. It will increase the durability. Here, once again, all the discussions we are driving to the single point: durability of the structure, sustainability of the structure. Whatever we are discussing here, all the roads lead to the durability of the cement concrete. So once again, I appeal to the researchers and academicians. Beyond these things, how we can think about, how we can visualize to increase the durability of the and sustainability of the cement concrete is need of the hour. Next, no water simple band ratio. Next, high workability, low bleeding, dimensional volume, high elastic modulus, low thermal stress, and low creep. Okay, these are the academic things. Next. So, which are the factors? Which are the factors affecting the durability concrete? The structural design, number one. Study of the environmental conditions, number two. I am more interested in a microstructure in this discussion now. So, in the microstructure of the concrete, water cement ratio, cement concrete, and material quality, a mixed design, workability, cohesiveness of concrete mix, and all these things will add to the durability characteristics of the microstructure. Next. So, we are discussing to increase the durability of the cement concrete. Okay. So what are the methods we adopt, we practice in improving the durability? So we have water, in the cement concrete, aggregates, cement, and in addition to that, we have pozzolanic and mineral admixtures, pozzolana or slag or some other admixture, we call it mineral admixtures, and chemical admixtures, chemical additives, which increase the durability of the concrete, which will have our main idea to make the concrete more durable. Mineral admixtures and chemical admixtures, where we are well aware. We have good knowledge about it. What are the mineral admixtures? We generally, everybody will fly ash and ice cast, silica fume, slag, metacoagulant. Next. Chemical admixtures. There are water reducing admixtures, retarding admixtures, accelerating admixtures. We are more concerned about the water reducing admixtures and high range water reducing admixtures and high range water reducing and retarding admixtures. Next. There are academically lingosulfonates or sulfonates and naphthalene sulfonates, polyacrylics, polycarboxylic ethers. So there are some other advanced chemical admixtures also. They are mostly water reducing admixtures. So once you reduce the water in the cement concrete, means we are reducing the pore volume, we are reducing the permeability, we are reducing the pore voids. So you are increasing the durability. Ultimately, our point, we will drive to that point only at point, how to increase the durability. So our primary objective is reduction of water cement ratio for a given concrete workability. Workability is we have to reach it, because without workability we can't place the concrete. Stiff concretes or hard concretes, when in the stage of production, wet concrete, we cannot place it in the farm work. We cannot cast the beams, we cannot cast the slabs, we cannot cast the columns. So workability, we cannot lose it. But for workability, we cannot add the water as academic or villain wish. So we have to reduce the water, we have to increase the retain the workability. Our aim is that to improve the durability. So what are these admixtures we use? We are now concentrating on the admixtures to increase the workability, decrease the water cement ratio. You can see the colloidal particles here. Once the admixtures added, they are dispersed. Dispersing agent dispersed. The colloidal particles are repelled from one another. So free water, entrapped water is released. The concrete is made more workable. Next. That is the entrapped water, the flagellated cement flakes. Next. So the trapped water is released. cement grains are repelled apart so that they are more workable. So with the given reduced water and optimum water, we say optimum water, we can increase the workability without adding extra water or using the admixtures, chemical admixtures, water reducing agent, super plasticizers. This is the academic part of this hydration of cement. We have here two parts here. How to release to increase the durable workability of the concrete, make it more durable. We add chemical admixtures and release the entrapped water in the gel and make it more durable, more workable, so that less water is added and more durable. Next, we are coming to the mineral admixtures part now. What is the role of mineral admixtures in increasing the durability of the concrete? Here I am trying to, this is academic thing. We are all academicians, know it. Here, calcium, tricalcium silicate and dicalcium silicate. In the tricalcium silicate, early strength is there. Pre-lime is 39% calcium hydroxide. And this pre-lime, earlier we have seen the retaining wall. This pre-lime is leaching from the structure, making it is less durable. Right. So calcium hydroxide, it is very dangerous material. It is pre-lime, we call it. So how to reduce this pre-lime? Because the leaching of the pre-lime causes the building porous, intercapillaries are connected, the reinforcement is rusted, the structure is more undurable, is structurally will fail. So you use the mineral admixture, fly ash or silica fume and other pozzolanic mineral admixtures to overcome the bad effect, ill effects of calcium hydroxide. Calcium hydroxide, in other terms, pre-lime is a cancer to the concrete. Two things are here in the cement concrete structures. One, rusting of reinforcement, one major item. Reinforcement cancer. Next, pre-lime, this is concrete cancer. So, as a research people, academicians, and industry people, our intention is to avoid both the cancers, reinforcement cancer and concrete cancer. Reinforcement cancer is rusting, concrete cancer is leaching of pre-lime. Next. Next. So hydration process, calcium hydroxide and calcium silicate hydrate. So when reaction, we add reactive silica. This calcium hydroxide reacts with calcium reactive silica, like fly ash or GGBS and reactive silica, and secondary reaction will take place, consuming the pre-lime calcium hydroxide, the concrete cancer will be reduced. So microsilica is very minute particle. It is some more than 100 times so less in volume when compared to the cement particle. This is a schematic diagram or picture. Next. Microsilica and pre-lime. This combination, every time I am very happy to see this. Microsilica or reactive silica and pre-lime. Because this reactive silica or microsilica or pozzolanic material reacts with extra lime and pre-lime, blocks the fine pores of the concrete. So you have to understand how it is increasing the strength of the concrete, how it is avoiding the pores, how it is arresting the capillary connectivity, how it is reducing the pore volume. this reactive silica or microsilica will be reacting with the free light and blocking and arresting and filling the maximum voids, all the voids, you can say, if you properly designed in the hardened concretes. So the finest of fine pores of the concrete will be filled and blocked and improve the mechanical strength and bonding strength of the concrete. So the combination of the free silica and free lime, very happy and good context for the cement concrete people. So this is the pozzolanic activity. Already we discussed with the reactive silica powders, slag, silica, fume, or DGPS, fly ash react with the calcium hydroxide in the presence of the water. Again, it will form calcium silicate hydrates. It is the secondary reaction known as the pozzolanic activity. We are all well aware of it. Some other all the conditions, these secondary conditions, secondary reactions will improve the durability of the concrete. There are some of the our IS 456 or the IS codes are defining some of the industry standards. Portland flag cement, already industry standards are there. Already quadral provisions are there. Portland pozzolana cement, PPC, major pozzolanic cements are under the IS code of 1489. And similarly, we have so some other codes are being developed, some other articles are being developed in the coming IS 456. Some more standards are being codified, or code of standards are being under the study. In the next release of the IS 456, we will have better codal provisions, clauses on the durability of the concrete, pozzolanic activity, reactive powder silicas or microsilicas. So myths and misconceptions in the cement concrete. Some I see whenever I discuss with some of the people, sir, this cement is very black, so it's very good. It is very hard gray. It is very good. Sir, the cement is a little bit some other biscuit, I can say gray color or white color. It's not good. No. The color of the cement depends upon the raw material it is used. Not necessarily dark gray cement or black cement doesn't represent they are better than the cements which are light in colors, which are light gray colors. Or some cements are maybe a little bit brownish, grayish white or something like that. So the strength of the cement or cement concrete does not depend on the color of the cement. It depends upon the constant materials, raw material from it is manufactured, how the cement raw material is designed, how they are pulverized, or they are run in the ball mill, and how the end product is there, what is the chemical composition, what is the hydration time, what are the final particles. So many things contribute to the strength of the concrete, but not the color. So I want to explain about the myths and misconceptions. Even the educated people also think that this concrete is black in color is good. It is not that much black. It is showing some gray color or light gray color. It's not black. No, the myths are to be dispensed. Next, say until this is we are coming to the end. I can from the say here top 4 photos or pictures are about the conventional concrete. The second row is regarding the reactive powder concretes, the silica concretes. So before abrasion, top surface is worn out. You can see in the conventional concrete. Some of the particles are dislodged or removed when abrasion is taking place. Next, pits are formed and causing cavities. I see it in so many CC road payments. Physically, I see over a period of time, when the OPC cements are not ordinary concrete cements are used, where finer binder material is not there, where the pozzolana activity is not there, they are not closely interconnected in the load transfer. So after top surface is worn out, smaller particles of the aggregates are dislocated, removed, pits are formed. Here, the second row, this top surface may be worn out a little bit, not that much when compared to the first sample. The aggregates are not removed or not dislocated. No formation of pits, no cavities. This is the use of the microsilica, real to silica. So durability, how you increase, we have to think on it and improve. At the end of the day, our intention is to improve the durability. So make the microstructure for a better load transfer mechanism. So these things are interconnected: durability, microstructure, load transfer mechanism, ore volume, capillary interconnectivity, everything. Next. This may be the end of it. Next. So once again, I thank my guru, Dr. M.V. Shashvi Rao Garu, a retired professor in civil engineering, joined to Hyderabad, who ignited my desire, who ignited my thirst in cement concretes and gave me encouragement to do some work in bacterial concrete. And I had done my PhD in bacterial concrete and self-healing concrete. I once again, and every day, I thank my guru. And I thank the management of the Koparaj Rangaraju Institute and the principal, the director, the HOD, and Dr. Srinivas. Anybody can ask me questions. And I also request suggestions for my improvement in the next presentation also.
Hello, sir. Night, sir.
Yes.
This is Satyanarayana from Koparaj Rangaraju.
Yes, sir.
Today we are all purchasing the concrete from RMC unit.
Yes.
But they are mixing only the manufactured sand or quarry dust instead of the river. But while you are designing, we are taking either zone 2 or zone 3 in case of the sands. But while they are mixing only manufactured sand, so that will be influence the, as per my knowledge, durability. So how much maximum percentage of manufactured cement sand can replace the river sand without disturbing of their durability properties of the any concrete, either M30 or M40 or whatever?
Yes. This is very relevant question. Recently also we had discussion in the other platforms also regarding the manufactured sand. Most of the RFC plants are directly without any analysis of the sieve analysis of the crusher dust or broken granite dust. They are calling it as manufactured sand. Actually, for manufactured sand or manufactured prime aggregate, there are industry standards. Already IS 456 is specifying.
What is the number, sir?
Hello?
Code number, sir?
The same code which is applicable to sand, the fine content less than 75 microns, less than 40 microns, or all the silt content portion which shall be avoided in the sand shall also be avoided in the manufactured sand. Actually, there are 1 or 2 manufactured sand factories I have seen which are used by the airports authority. There, they washed the manufactured sand in the huge tanks so that the final silt content is removed and that is used for the in place of the sand. So the danger part of the silt content, the particle which is lesser than 75 microns, lesser than 75 microns will contribute to the silt content, swelling property, and cracking of the. It is nothing but clay, less than 75 microns. So we have to avoid that 75 microns in the coming code also. So there are some people which are using in the industry people who are executing the concrete works of more than 20 crores or 30 crores. Temporarily, they are establishing their own RMC plants on the lease basis in their premises to avoid the problem which is focused by our Dr. Satyanarayana Garu. Because our Dr. Satyanarayana Garu has correctly pointed out the problem already, which most of the people are facing. But why it is not being addressed? Means now it is need of the hour. It is being addressed by the research people. It is being addressed by the IS 456 also. In the next 2020 IS 456, the industry standards of the manufactured sand will come. So unless otherwise we insist and emphasize somebody, when we are buying the RMC, we sit in the RMC plant, some technically qualified person, analyze the geo analysis of the manufactured sand, then only we can achieve the required fineness modulus and we can avoid the silt content in the manufactured sand. It is a problem. It is not solved anywhere in the country. It is only one or two plants which are very good in rules and regulations and ethics. Those RMC plants only giving good RMC. Others are simply mixing the dust or the 12 mm and 20 mm gradation and the dust 6 mm and 4 mm, 2 mm and dust more than 5%. Then is also mixing with the cement concrete. Their unethical practices are there. It is to be addressed.
Okay, sir, I have one more question, sir.
Yes.
Sir, generally, whenever you are seen in Hyderabad or anywhere in high-rise constructions, almost all builders are using the self-curing concrete, self-curing agents instead of the concrete. Is it durable?
Yeah. Self-curing compounds. There, some people have practiced. Say, let us say, M40 is required. Let us say, some good construction companies are designing for M50 also. But they are using the factor of safety. They are taking 1 or 2 companies I have discussed. They are designing for a 5% or 10% higher strength and using the construction practices. I can't say all are bad. Some are good people. Some are the super Rusums also there. Some of the industry people. It is always there, good or bad. Unless otherwise we analyze from case wise which are the practices they are using, which are the codes they are using, what is the design strength they require, what are the cement RMC they are getting, what are the procedures they are using for self-curing or surface curing. We can assess case by case only. We cannot generalize.
Okay. Okay, sir. Thank you for your respective answers, sir.
సార్ నమస్కారం అండి.
నమస్తే సార్.
నా పేరు జంశాల నారాయణమూర్తి.
తెలుసు సార్, మేము have seen you sir in the 1 or 2 sessions sir.
Okay, so
I attended college also. You know.
Sir, as much as you regard Seshagiri Rao Garu, we also have a strong affinity and connections with him, and yes, we are also grateful to have such a nice, wonderful association with that great engineer, sir. Faculty come engineer, man, and we also benefited from his constant guidance to our departments.
Yes, sir.
Sir, as a non-civil engineer, because I am from mechanical engineering,
yes, sir,
so I ask a question, sir. I would have preferred to see more examples in your presentation, sir, in the sense You have mentioned that even your PhD is on that self-healing concrete. Maybe an existing structure or structures where they're using as a model example, if you had given either a governmental or non-governmental structures, I would have, appreciated saying, yes, this uses some microsilica, or this uses self-healing concrete, etc. If any examples are there, I would prefer that, sir. Thank you.
Actually, as a practicing engineer, I use slag cement, sir, for 100, not a single work. In the next session, I will do the compressor time, photos, and everything. I myself, because for the last 15 or 20 years, I am associated with Shashgi Rao, sir. So he encouraged me in using and improvising the durability concretes. It is the teachings of the Shashgi Rao for the last 20 years, sir, increasing and making me learn about the durability. I used it for Munneru Bridge, PPC cements, slag cements. I used it for NCRFP works as an executive engineer, as a super engineer. Their live examples are there, sir. And in one session, for a short session, with the photos also I will give, sir.
Yeah.
That
will at least enforce our understanding, sir. Thank you.
Thank you, sir.
Yeah.
Thank you, sir.
Good afternoon, sir. This is Hemlata.
Yes.
Sir, I have a question like this silica fume properties, which are very important in this concrete cement replacement. And I have studied few papers like alkofine is using as another material in place of silica fume because it costs more. One bag, it is cost almost 10,000, 10 kgs. So it is this alkofine is having the similar materials. It is replacing the silica fume also. Does it really works? Any chance that you have gone through?
So is it having the properties of silica, react to silica?
Yes, sir. Yes. I've gone through few journals. I don't know practically it is worked or not. Reputed journals only I've gone through. It is really worked, they said. So is it, have you gone through in practical conditions or like? Because in my PhD work, I was doing, one bag, it costs almost 10,000. So if they are saying many papers are there, they are replaced with alkofine, 1203, some properties are there. So it has replaced that and giving the similar strength and workability.
Then we can work on it. I will discuss with our Dr. Srinivas Garu and I will coordinate with you.
Okay, sir. Thank you. Thank you so much.
If you have any queries, please unmute yourself and ask.
Looking like no queries, sir.
Yes.
Sir, looking like no queries, no further queries.
Okay.
I think.
Okay.
So, is it audible to you, sir?
Yeah, audible.
Yes, sir. So, sir, in spite of your busy schedule, you spent your valuable time and explained very well about durability of concrete, high performance concrete, structure of cement concretes, microstructure of cement concretes, about interfacial transition zone, and about the leaching of free lime. So it's thank you very much, sir.
Thank you.
Okay. If no queries means we can wind up.
Okay, sure. Thank you, one and all. Thank you, management. And thank you, principal. Thank you, the director, HOD, and thank you, Dr. Srinivas and other members.
Dear participants, tomorrow we have good session on importance of civil engineering in electrical power transmission. So by Dr. T. Venkateshwar Rao, sir, Executive Engineer Civil, is working in Telangana State Transport Department. So please, all of you can log in by the same time, about 2:15 p.m. tomorrow. Thank you, one and all. Thank you very much.
Thank you. Thank you, Ananda. Leave it.
Okay, sir. Thank you.
So there is a question in chat box. There is a question in the chat box.
What is the highest grade of concrete? According to IS 456, it is MIT. According to IS 456, now it is MIT is the highest concrete. In the next code, we have to see. Yeah, MIT is the highest concrete.
Okay, sir. Thank you. Thank you very much.
Thank you.
Praveen sir, Prakash sir, shall we end the session?
Hello?
Yes, sir. Yes, sir.
Okay.
Yeah.
Okay.